Hello everyone, and welcome back to the channel. Today is October 3rd, 2025, a lovely Friday. You know what that means. It's time to pull a super interesting, trending article from the archives. Alright, let's see what we've got today. This looks cool. It's about making AI that understands music. Less about, mysterious black box. The title is MUSE-Explainer Counterfactual Explanations for Symbolic Music Graph Classification Models. The plural is G. Mit Hauptsache. Hauptworte. Divided 9.26,521. It's long. So, let's get into it. You know how we call these incredible AI models now that can listen to a piece of music and tell you, oh, that's definitely Mozart, or that part right there is a perfect cadence. They're super smart, right? But there's a huge problem. If you ask the AI, why is that a cadence? It just kinda shrugs. It's a black box. It knows the answer, but it can't explain its reasoning. This is a big deal because if we want to use AI for things like teaching music, helping composers, we need to be able to trust it. And to trust it, we need to understand it. Some people have tried to make AIs explain themselves before. The problem is, these older methods often create explanations by making random, nonsensical changes to the music. It's like trying to understand a sentence by replacing a word with gibberish and seeing if the meaning changes. It doesn't really work and can lead to really unstable and confusing results. So this paper introduces a new tool to fix this, and it's called MUSE-Explainer. I love that name. The MUSE-Explainer is built on a really friendly idea called natural explanations. That sounds complicated, but that's basically just asking, what if? It works like this. Let's say an AI model is 99% sure that a specific part of the song contains a perfect technique cadence or a path. MUSE-Explainer will then make the smallest possible change to the music to make the AI change its mind. It might find that if you just remove one single note or change its pitch slightly, the AI suddenly says, nope, that's not a cadence anymore. And just like that, you get a clear, understandable explanation. The AI thought it was a cadence because of that specific note. What's really clever here is how it represents music. It doesn't see a score as just a list of notes. Instead, it builds a graph like a connected web. Each note is a note or node in the graph, and the lines connecting them represent their relationships. Like these two notes are played at the same time, where this note follows that one immediately. This lets the AI see the complex structure of the music, which is how it makes such good predictions in the first place. And the best part is MUSE-Explainer only makes changes, but are musically coherent. It has 5 specific added operations it can use. It can change a note's pitch, its start time, or its duration. Or it can add a new note or remove an existing one. By sticking to these rules, it ensures that the what-if scenario it creates is still a valid piece of music. It avoids creating that musical gibberish I mentioned earlier, which makes its explanations so much more reliable and insightful. This is a big step up from other methods. Some older techniques, called model methods, needed to have full access to the AI's brain, which isn't always possible. And other black box methods, like Lime or MUSE-Explainer, were the ones that had issues with creating nonsensical data, which this new approach completely avoids. This reminds me of a joke. Why did the Graph Neural Network bring a ladder to the concert? Because it wanted to reach the high notes in the data structure. Right, moving on. So where could we actually use this? The applications are super exciting. Let's think of 3 examples. First, music education. Imagine an AI tutor for music composition students. A student writes a melody, and the AI says, this sounds more like Bach than Mozart. You are trying to imitate. With MUSE-Explainer, it could then highlight a few notes and say, if you changed this G to a D sharp and shortened this other note, the model would classify it as being much more Mozart-like. That's incredibly specific and helpful feedback. Second, think about tools for professional musicians and composers. A composer using a digital audio workstation can get suggestions to refine their work. Let's say they're trying to write a track for a movie scene that's supposed to feel tense, but the AI classifies the music as calm. MUSE-Explainer could point out that removing a specific background harmony or changing the rhythm of the bass line. That's all it would take to flip the AI's prediction to tense, and then for games and interactive media. A lot of modern games use procedural music that adapts to what's happening. Like a game is supposed to generate exciting combat and music, but it sounds kind of flat. Developers could use this tool to think about it. It could reveal that, hey, the AI thinks the music is calm because the drum pattern is too simple. Adding a few extra notes is what would make it sound exciting. In the paper, the researchers tested this on a real task. They used an AI model that was trained to detect cadences in Mozart's piano sonatas. They showed that MUSE-Explainer could successfully find tiny changes that would flip the model's predictions. For example, in one case, the model identified a cadence because of a specific harmonic structure involving a suspension note. MUSE-Explainer figured out that just by removing that one suspension note, the AI would no longer see a cadence there. It's so cool because you can actually see and hear the exact musical element that the AI is paying attention to. So, to wrap it up, MUSE-Explainer is a really important step towards music AI. More transparent, trustworthy, useful in the real world. It's the first counterfactual explainer designed specifically for this kind of music data. The authors say that for future work, they want to make it even more efficient and apply it to more complex tasks, like explaining why AI thinks a whole piece of music was written by a certain composer. This is the kind of research that bridges the gap between raw technical power and genuine creative partnership with AI. Super fascinating stuff. Anyway, that's all the time we have for today. Hope you found it as interesting as I did. Let me know what you think in the comments below, and I'll see you next time.